Okay, in part C, we want to find the x-coordinate. Notice it doesn't ask for the coordinates or the x and y coordinates, but it just asks for the x-coordinate of each point of inflection of the graph of f and to show the analysis that leads to your conclusion. Okay, so we know that the points of inflection um, are where the original function changes concavity. That is where the second derivative changes sign. That's all we're looking for, is where the second derivative changes sign. So I will go back, when I'm trying to find the second derivative, I will go back to the original form of the first derivative, which is the 12x to the third plus 3x squared minus 42x. It doesn't really help me to work with that in factored form because then I'd have a product rule with three different factors to consider. So I go back to the original derivative, and I find that the second derivative is 36x squared plus 6x minus 42, and that will equal 0 when 6 times the quantity 6x squared plus x minus 7 is equal to 0. Now I multiply 6 times negative 7 and I get negative 42. So I'm looking for two numbers that multiply to give me negative 42 and add to give me positive 1, so it would be positive 7 and negative 6. And so I use positive 7 and x and negative 6x to rewrite the middle term of x. And when I do, my final factored form comes out to be 6 times the quantity x minus 1 times the quantity 6x plus 7. So I have two values there that are potential points of inflection. But remember, I have to show that in order for them to be genuinely points of inflection, the second derivative must change signs there. And so I use a number line with the two numbers negative 7/6 and 1. For test values, I'll use negative 2, 0, and positive 2. And again, when I am going to test these values in the second derivative, I would go to the factored form of the second derivative, because it makes the computation a lot easier. So with the first one, negative 2 minus 1 is negative, and 6 times negative 2 is negative 12, so it's going to give me negative times negative, which is positive. Plugging in 0 gives me negative 1 and 7, so it's negative times positive, which is negative. Plugging in 2 gives me positive, positive, which is positive. And so points of inflection are 1 and negative 7/6. And not just because the second derivative was 0 there, but most importantly because the second derivative changed signs at those 2 points there, and we have demonstrated that. Right, so we have found the x coordinates of each point of inflection, and we showed the analysis that led to our conclusion. What was the basic analysis? We found the second derivative. We set it equal to 0. We found the x coordinates that make the second derivative equal to 0, and we tested values on either side of those potential points of inflection, and we found that the sign of the second derivative did in fact change at each of those points, and so they are the points of inflection. X equals 1 and x equals negative 7/6. So that brings us to the end of this problem.